Hi everybody, Dr. Bardo. Uh, Tonight we're going to make actuator rama. This uh, be something that looks like this sketch here. It's going to have a button, a light, a piezo, and a servo. What's it going to do? Well, once you start uh, the simulation, the servo might move a little as it gets into its standard position, but then everything should be still. When you press the button, your light maybe will just go on or maybe it will flash. I think in the end I'll make uh, an example where instead of flashing it just goes on. And then if you press the button again, so you're going to get a piezo ring, and if you press the button again, you get the servo to jiggle. If you press the button a fourth time, everything is off. You can see I'm getting a little bit of problems with debouncing here, where either when I press the button it doesn't register or it sort of registers double. So that time it worked fine. So I press it once. I press it again. I press it again. I press it again. Perfect. That's how it's supposed to go. All right. Let's make this from scratch. So I'm going to make a brand new tinkerCAD sketch. Begin in the standard way. So I'm going to grab my Arduino. I'm going to grab my breadboard. I'm going to connect 5 volts to the power rail here. And I'm going to connect ground to the ground rail. First component that I want to put on is my push button. I'll put it down here for now, rotate it. Connect one side to power. And create a resistor, a 10K resistor that's going to connect to ground. Then I'm going to connect the ground side of the button to my Arduino. All right. Having put on a component, I want to make sure I can make that component work. So I'm going to put in a little code. So just change, we'll just take all of these, all the code that's in here except for the void loop and void setup pieces out. So pin mode 2 is where I connected my button. I'll need a variable to represent the reading of my button, and I'll need to check that reading with a digital read of the proper pin. To really get a sense that it's working, I'll want to use serial. I want to use communication with my computer. So I'll say serial begin 9600, and then I will print and go down a line the value that the button has been given. So that's really basic code to make a button work. You're going to have a variable. You're going to say pin mode input. You're going to read and put into that variable whatever amount of electricity is being sent, either high or low. And then later you're probably going to use that variable button, in this case, to make decisions about what to do. But we're going to hold off on that now. We're just going to print out what's going on. So let's go ahead and start the simulation. look at my serial monitor, you can see that I'm getting zeros on my serial monitor. When I press this button, I want to see ones. So when I press it, there are ones. When I let go, there are zeros. Press ones, let go zeros. That means my button is working. So I'm all set on that. I'll stop my simulation and bring in a new component. So the next component I'm going to bring in is my LED. I know that I want to connect the ground, the cathode of my LED to a 220 resistor. And I know that I want to connect the anode of my LED to my Arduino so I can control the power that comes out. I can control when the LED is receiving power. All right, I've wired up my my LED. So let me add a little code to see if I can make that work. Just really basically, not with the button, but just by itself. So first thing I do is I say pin mode 3 output, and then here I'll say digital write 3 high. And let's just do that so that I can see this will just make the light light up. Can I make the light light up? That's my question. So I'll run the simulation and the light lights up. Huzzah. Okay. Next step is to get a piezo, place it, connect one side of it to ground, and connect the other side to a pin. So I'll use D4. Now I want to see if I can make that make a noise. So let's go in here. I guess I'll say pin mode 4 is an output. Sorry. Pin mode 4 output, and then tone for 440. That's the tone I want to create, and I'm just going to do it for 100 milliseconds. So you can see very simple code here right now. Just make sure your components work, and then we'll work to make them do their separate things later. Okay. Step by step. We do start simulation, get the light, get the sound, see the button still working. Perfect. Okay. Next, the last piece, the last component that we need is a servo. So I'll grab one of these. Now at this point, it's a little hard to see the colors on these in here. So I just, when I flip through it says what it is. So ground will go to ground. It's useful to make power will go to power. And when you find these in real life, they don't go in this order all the time. You really have to look and read the documentation that come with your servos to make sure that how they work. An important thing with servos is that those servos have to be connected to the Arduino at pins that have the little tilde symbol in front of them. That means that they have power width modulation, and it allows them to send a lot of different signals which are necessary to control the servo. Okay, so let's just make sure my servo can be controlled, can move. So we'll put in some code here. This is going to be the most code we're going to have to do for anything. The first thing we need to do is we need to load up the information that Arduino will need to run a servo. So be sure to put a capital S on your servo.h here. H means header. And then we're going to need to tell it that we're going to have a servo. I'm going to name my servo Tony with a lowercase t. So I've just decided to name him Tony. Just to give you a sense that it doesn't always have to be my servo. But just like we've pin moded all of our other components, we need to do some setup for the servo. The servo is much more complicated, the most complicated piece of equipment that we have here. So we're going to use some code from the library that does all of the little things that need to be done to make the servo ready to run, ready to work. And then, so that's Tony.attach 5. 5 is the pin that I connected the servo to. And then I'll say Tony write 0 and a little delay to make it wiggle a little bit. And Tony write 180. I just want it to wiggle and delay 100. So I'm just putting all these pieces together at once. I want them all to work. It's not exactly at the same time, but very close to contemporaneously. In fact, let's just try even a little shorter here. Let's say 50. We'll see if we can see things move when we do that, so that each thing is taking about 100 milliseconds, which is a tenth of a second, hopefully not too long. All right, so here I go. I'm going to start my simulation. My light's on, my servo is wiggling, and my button is reading. So everything's working perfect. Great. So close to being done now. The last thing I need to do is what I sort of talked about in class today. We need to set up a state variable that's going to tell me what's going on when. Okay? So, and then we're going to take our different actions and break them up into different if statements. So if that state that I just defined is 1, we're going to light up the light. And then we'll say else if my state that I just defined is equal to 2, then I'm going to make a sound. And then I'm going to say else if my state is equal to 3, we'll wiggle the servo. And finally, else, well, I should do this. So the tricky thing here is that once you turn on a light, the only way to turn it off is to tell it to turn off. So I should throw in here a digital write 3 low. So after I have the light on, when I hit the button again, I want to make a sound and turn the light off. So I'm doing those two things here. And that's it. When the state is 0, it should do none of these things. So I could have an else here, but I don't have anything to do. So I've dealt with how state is going to control what thing we do. If state is 1, turn on the light. If state is 2, turn off the light and make a noise. Else, if state is 3, wiggle the servo. So what I really need to do now is use the button to control what state I'm in. So here's where we will say if button is equal to high if I press the button. Then let's make state be 1 bigger than it used to be. For the most part, that'll be great. If state is 0, it'll move to 1. If state is 1, it'll move to 2. If state is 3, it'll stay as 2 and move to 3. If state is 3, it'll move to 4. And that's where things start to go bad. I want my states to be 0, 1, 2, and 3. 0, 1, 2, and 3. Those are the only numbers I want there to be. So I need to throw in here one more question, which is if I've made state too big, if I've made it equal to 4, then make state roll back to being 0. And as you saw, it's good to have a little delay after you change your state. Because, and I'm going to play with 200 here. What you don't want to happen is, this is called debouncing. You want it when you press the button, you only want it to be red once. So hopefully you're pressing the button for about a quarter of a second or something like that. Okay? All right. So what did we do that was different from before? We added if statements so that we would get three different actions, really 4 different actions, because the 4th action is to do nothing. Okay? And then we made an if statement when the button is high to change which state we're in, to change which of the components we're going to use. So let's see how that works. I'll start the simulation. This movement is fine. This is the servo getting into standard position. Totally fine. And now we're going to hit this button, and hopefully we will see the light turn on. Okay, so good. We'll hit the button again and hopefully hear the noise. And the light turns off. Perfect. Hit the button again. And it wiggles. Hit the button again and we want it to see it stop wiggling. So it turned on the light, which wasn't great. And that problem is the debouncing. So I did it again, and I didn't hold down the button quite as long, so I didn't go through 2 steps. That's the challenge of debouncing. There's some more complicated ways to make debouncing work, but I wanted to show you the simplest way tonight. I hope this lesson makes sense to you. I hope you can see how you can use this lesson to wire up lots of different components and control them and create programs that use sensors to control them with if statements. And I'll be in the lab tonight to answer any of your questions. Have a good night.